Welcome to the deep dive. We really try to crack open complex topics and just give you what you need to understand them.
Yeah, get right to the heart of it.
Exactly. And today we're diving into, well, the fascinating and sometimes, honestly, a bit unnerving world of AI training. These large language models, LLMs, they often feel kind of magical.
They really do. The capabilities are astonishing sometimes.
Yeah, conjuring text, answering questions, writing code. It feels almost impossibly smart. But behind that magic, there's a less glamorous truth about how they learn and maybe more importantly, what they might accidentally memorize.
That's the crux of it. It's often called the most expensive bug in modern AI, accidental recall.
Wow. Okay.
These models are basically amazing pattern matchers. So if a specific phrase, maybe a personal ID, or some sensitive data string shows up a lot,
Right.
or just in a really strong context during training, well, the model's learning process, gradient descent, often just finds the easiest way to reject error is simply to store it.
Just memorize it wholesale.
Pretty much. And this isn't just theory. People have shown you can prompt models carefully and get them to spit out private strings.
Yeah, that's a huge risk.
Yeah.
Personal data, company secrets.
Exactly. And it erodes public trust, which is critical for AI adoption.
So if you're out there building with AI, or maybe you handle sensitive data, or honestly, if you're just really curious about how AI is tackling these huge challenges,
And you're in the right place.
then this deep dive is definitely for you. Today, we're going to dissect this solution from Google called VaultGemma. And our mission is to really understand what they mean by a clean room foundation for private AI training.
Right. Building privacy in from the ground up.
Like actually woven in from the first token to the last, as they put it. We'll look at what that means, why it matters, and importantly, how you might actually use it.
Okay.
All right, let's unpack this memorization thing a bit more. It sounds weird almost. Why does it even happen? And why is it so hard to stop?
It's a really fundamental question. Basically, the whole training process is optimizing one thing. Next token prediction.
Predicting the next word, essentially.
Exactly.
Right.
And if you have data that repeats a lot or has a really strong signal, think like a unique ID again or the very specific sentence. Well, the easiest way for the learning algorithm for gradient descent to get better at predicting is just to memorize that sequence.
It's the path of least resistance for the math.
Precisely. It lowers the model's loss, its error, really efficiently. Now, sure, you can use techniques like regularization or carefully deduplicating your training data.
I'm trying to remove those repeats.
Right, and that helps. It definitely chips away at it. But here's the key thing. Those methods don't give you mathematical guarantees.
So no absolute certainty.
Nope. A non-private model, even after cleaning, might still, under the right prompting, give back sensitive stuff it saw.
So even with all that data cleaning and deduplication, if there's no guarantee, does that mean maybe we've been underestimating this risk in how we build AI now?
I think many people would say yes. And it points to a really common and actually quite dangerous misconception.
Okay.
Well, you often see teams take a big, public, pre-trained model.
Yeah, like off the shelf.
Exactly. And then they fine-tune it on their own private data, thinking, okay, now it's safe for our use case.
Right. Makes sense intuitively.
But that base model, the public one, it's kind of a black box, isn't it? It was trained on this huge, messy mix of public web data. If that base model already memorized sensitive things from its training, which it almost certainly did, your private fine-tuning later on will not unlearn them.
Wow. Okay, so you might stop at learning new private stuff from your data.
Right. You might limit the new risks.
The old risks are still buried in there.
Exactly. They're baked into the foundation. So for anything really high stakes, the only truly secure way is private AI training from scratch or starting from a base model that was also trained using differential privacy.
That's a massive difference. It really shifts the perspective. It means a lot of what people think of as private AI today might still have these hidden vulnerabilities.
It really highlights the need for a truly private foundation.
Which brings us squarely to VaultGemma. So we've set the stage. We see the problem. What is VaultGemma specifically?
So VaultGemma is a 1 billion parameter decoder-only transformer.
Okay, 1 billion. That's a decent size, but not enormous like some models.
Right. And it's built in the Gemma lineage, which is Google's open source family. So the architecture is familiar to a lot of developers.
That helps with adoption, I imagine.
Definitely. But the absolute key difference, the core idea, is that it layers in a strict privacy mechanism during pre-training.
Right there in the foundation.
Exactly. The goal is an open, research-friendly baseline focused squarely on LLM data privacy, and critically, something you can actually run for inference on commodity GPUs.
So bringing this provable privacy out of the lab and making it more accessible.
That's the idea, making it practical.
Okay, so 1B parameters, Gemma family. What about things like context length? And what are the intended jobs for this model?
Good questions. For pre-training, it uses a 1024 token context length. This shorter context actually helps manage memory when you're using the really large batches needed for private training.
Ah, connects back to the training method.
Right. And its roles. Well, it's great for research into privacy-preserving NLP, obviously. Ideal for pilots in sensitive areas like healthcare or finance.
Where data leakage is a nightmare scenario.
Absolutely. And it's even useful for education, actually, showing people how differential privacy works with a real model, not just theory.
And you keep mentioning this strict privacy mechanism. You used the word guarantee earlier. How does it actually guarantee privacy? Because, guarantees in AI feel rare.
They are rare, and that's why this is important. VaultGemma offers a sequence-level guarantee. It uses differential privacy with parameters called epsilon and delta. Think of epsilon as, like, a maximum budget for information leakage about any single training example. And delta is the tiny, tiny probability that even that budget is exceeded. VaultGemma aims for tut epsilon and tiny delta.
So very little leakage allowed and almost zero chance of breaking that limit.
Exactly. In simple terms, if a private fact was in just one training sequence, someone querying the final model should find it statistically impossible to tell if the model saw that sequence or not.
Like finding one specific grain of sand on a beach.
That's a great analogy. Now, if the same fact appears in many sequences, the model might learn the general concept, the aggregate pattern, but it becomes incredibly hard to trace any one example back to its source.
That's the key. A formal mathematical guarantee, not just a policy or a best practice. That feels like a really big deal for anyone handling sensitive data.
It is. It changes the conversation from we hope it's private to we can mathematically bound the privacy.
Okay, let's peek under the hood a bit more. This guarantee comes from differential privacy, DP. Can you give us the quick elevator pitch on DP? What is it, fundamentally?
Sure. The simplest way to put it is math that limits how much a model can learn about any single record while keeping the global patterns intact.
So, learn the forest, not the individual trees.
Exactly. You decide on a privacy budget beforehand, you train the model using carefully added noise, and you have to stop training when that budget is used up. It's rigorous.
So there are actual numbers, hard limits. How does that work during the training itself? What's the mechanism?
Right. VaultGemma uses a method called DP-SGD. That's differentially private stochastic gradient descent. It's mostly like normal SGD, the standard way models learn, but with two really crucial extra steps. First is gradient clipping.
Gradient clipping.
Yeah, imagine each piece of training data is trying to shout its influence at the model. Clipping basically puts a limit on how loud any single piece of data can shout. It bounds the influence so no one example can dominate.
Got it. Like a volume control for each data point.
Kind of, yeah. Then second, after clipping, you deliberately hide what remains behind Gaussian noise.
Adding noise. Doesn't that hurt the learning?
It can, which is why it has to be done carefully. It's not just random static, it's mathematically calibrated noise. And then there's a privacy accountant that keeps track of how much privacy budget you're spending with each step.
Ah, the accountant.
Yeah. So if your budget is, say, epsilon 2, you cannot spend epsilon 3. It enforces the limit. No wiggle room.
That's incredibly clear. The accountant analogy really helps. And you mentioned something about a noise-to-batch ratio being important. A quiet dial.
Ah, yes. That's super important and often missed. It's the balance between how much noise you add and how large your training batches are.
Okay.
If you just add lots of noise with small batches, you'll drown out the learning signal. The model learns nothing useful. But if you significantly increase your batch size along with the noise, the useful patterns start to emerge from the average, while the randomness helps maintain privacy. It lets you average away randomness while keeping the privacy ledger in check.
So bigger batches let the real signal come through the noise while still meeting the privacy math.
Exactly. It's a key tuning parameter for making DP work well in practice.
It's really clear this isn't just theory. It's very practical math, changing how the AI learns right from the start, not a patch applied later.
Precisely. It's privacy by design.
Now, you mentioned monster batches and how private training inverts old instincts. That sounds really interesting. What did the VaultGemma recipe actually look like? How do they build it?
It does feel a bit upside down compared to standard training. Normally, you might focus on bigger models, longer context.
Right. More parameters.
Yeah. But with DP, because you're adding noise on purpose, you have to fight against it to learn effectively. That means you need those monster batches, cautious schedules, meaning slower learning rates maybe, and keeping the context length manageable for memory with those huge batches.
So huge batches are key. That sounds computationally intense.
Yeah.
And maybe awkward for the hardware.
It can be. Which leads to a neat engineering trick they used: truncated Poisson subsampling.
Truncated Poisson.
Okay.
Sounds complex.
The math behind it has roots in pure Poisson subsampling, which is nice for privacy theory but gives you variable batch sizes in practice.
Which GPUs and accelerators don't like.
Exactly. Very awkward for accelerators. So truncated Poisson basically says, pick examples independently like Poisson, but then pad the batch if it's too small or trim it if it's too big to hit a fixed size.
Ah, a practical compromise.
A brilliant one. Because you preserve the privacy math, you preserve throughput, and your hardware team stays happy. It's one of those smart, practical choices.
Making the math work with the machines. I like it. What about scaling laws? You mentioned those help decide where to spend compute.
Yeah, the team developed this really compact and useful scaling law. It predicts how the model's performance, its loss, will change based on model size, training steps, and that noise-to-batch ratio.
Okay.
And what's super useful is, for a fixed privacy budget, the law generally says, spend compute on bigger batches first, then maybe more training steps, and only then consider making the model itself bigger.
So it guides your investment. Batch size gives the most bang for your buck, privacy-wise.
Often, yes. It helps you decide where to spend before you commit to a massive, expensive training run. And for VaultGemma, the actual training results landed really close to what the law predicted.
That builds confidence. You can plan better, know what to expect before the bill arrives, as they say. It makes it feel much more practical for developers.
Exactly. Less guesswork, more principled engineering.
Okay, so we've gone deep on the how. Fascinating stuff. But now, the big question for anyone wanting to use this, how does VaultGemma actually perform? What do the benchmarks say?
Right, performance. And it's crucial to remember benchmarks are not reality, they are compass points.
Good caveat. They guide, they don't define.
Precisely. And what the comparisons show today is, yes, there's a real utility gap between a private 1B model like VaultGemma and a non-private 1B model.
Okay, how big a gap are we talking?
Well, take a common sense reasoning benchmark like HelloSwag. VaultGemma gets around 39%, while a similarly non-private model might hit 61%.
That's a noticeable.
It is.
Yeah.
But here's the interesting part. That 39%, it lands near non-private models from a few years back.
Ah. So it's not like it's useless. It's comparable to slightly older but still useful non-private AI.
Exactly, and that's why the source says this gap is not failure. That is a roadmap you can plan around.
Right. It frames the choice.
It clarifies things.
Wow.
Your only goal is topping leaderboards, maxing out raw benchmark scores. You probably still pick a non-private model today. But if you need that formal bound on leakage, if privacy is a hard requirement,
Then you have a viable option.
you have a capable private model. And honestly, think about many real-world applications. They do not need to ace HelloSwag.
True. They need domain-specific accuracy, good summaries.
Exactly. They need to answer domain questions, summarize records accurately, and stay inside a clear risk story. And in those contexts, VaultGemma is often already inside the useful envelope.
And presumably this is a moving target, right?
Yeah.
The recipes, the data, the hardware, it all gets better. That gap should shrink.
That's absolutely the expectation. This is a baseline, a starting point. The field moves fast.
So for listeners thinking, okay, maybe this is the solution I need,
Yeah.
what are some good use cases? Where does VaultGemma fit best?
It's really well suited for sensitive data workflows. Think processing clinical notes, insurance claims, maybe internal HR chats.
Anywhere confidentiality is absolutely key.
Right. Also for building privacy-first chat and co-pilots, where you really want to prevent the model from blurting out something it memorized inappropriately.
Makes sense.
And then there's research providing that credible baseline and education, like we mentioned, using it in labs or demos.
Okay, practical uses. Now, if someone downloads it, what are the key tips? What should they do, and maybe what shouldn't they expect?
First big tip. Treat it as a foundation, not a finished assistant. It's a base model.
Got it. Needs fine-tuning or integration.
Right. Run some initial tests, prompt it carefully to see what it knows and where that knowledge seems to come from. If you do fine-tune, seriously consider using DP-SGD for that step too, to maintain the privacy guarantee.
Keep the privacy going.
Yes, and critically, add policy layers. DP protects the training data, but it does not enforce content policy or safety by itself. You still need guardrails for output.
Super important distinction. DP isn't a safety filter.
Correct. Also, keep probing for memorization. Use things like prefix-suffix tests regularly. Put it in your CI/CD pipeline.
Okay. Any other practical nuggets?
Yeah, a few. For adapting it with DP, shorter sequences often work better. Double-check your clipping and noise settings get those wrong, and the privacy guarantee might not hold. Budget time for hyperparameter tuning. It can take longer with DP. And yeah, expect a speed tax during private AI training. It's often slower than non-private training.
Good heads up. Plan for the overhead. So that covers the do's. What about the don'ts? What does VaultGemma not do?
This is crucial. It does not replace content safety systems, it does not guarantee factual accuracy, and it does not make bias vanish.
Right. DP is about input privacy, not output truthfulness or fairness.
Exactly. Differential privacy only limits how much the model learns from any one sequence. It doesn't control what it says later or ensure it's unbiased. Bias often comes from the data itself.
If the bias is widespread in the data.
A private model can still learn those biased correlations. DP doesn't magically fix biased data.
So it really drives home that point. You need privacy tech, plus policy, plus evaluation, plus human oversight. It's a whole system.
Absolutely. Especially in sensitive areas like health or finance. Think of privacy as one leg of a three-legged stool. The other two are safety and reliability.
Good framing.
Monitoring, testing, evaluation, they all still matter immensely. The big promise of VaultGemma is that verifiable restraint. It's the guarantee the model won't just memorize and repeat a single sensitive record later on.
What a journey through VaultGemma. It really feels like the AI community asked for something like this: open, credible, actually useful for private AI.
And VaultGemma seems like a really strong answer. It proves DP can scale beyond small demos.
Yeah, it provides that community baseline, lets people build on it, compare against it, and it reframes that old privacy versus utility trade-off.
Makes it feel like an engineering problem you can actually solve, not an impossible choice.
So what's the call to action then, for people listening who deal with sensitive data?
The message is pretty clear. Start moving. Download the model, set up a small pilot study that reflects a real task you have.
Test it out.
Yeah, measure its quality, its speed, its privacy. Compare it to what you use now. If it meets your needs today, great. You earn a cleaner risk story and a better trust story.
And if it doesn't quite hit the mark yet?
Publish your findings. Share what worked, what didn't. That helps everyone push the recipe forward. Maybe it needs bigger batches for your task or different data prep. That's how the whole community closes that utility gap.
That's a fantastic call to action. Collaborate, share, improve the recipe. And it reminds me of that final thought from the source material that really stuck with me.
Which one was that?
Privacy is not a roadblock. It is an engineering choice. VaultGemma proves the choice is viable.
Powerful.
Yeah. Build something your users can trust and then invite them to hold you to it. What a great note to end on for thinking about the future of responsible AI.